Make all words React Genie red and bold.
It's good? Okay, perfect. Yeah, so Monica told me she's at some conference, I assume EMLP right now. So I'm teaching a guest lecture about multimodal applications. So I'm Jackie Young, and I read Monica's name. She helped me work through a lot of the slides here. A little bit about myself. I am Jackie Young. I'm a PhD but dissertation. Haven't submitted my dissertation yet with Professor Monica and Professor James Landay. And my thesis is about multimodal AI augmented user interface development architecture. So this entire architecture about how do we help people build better multimodal interactions. And right now, I'm working on a startup called Skywalk, and I'm VP of Software and ML. And then I do always available private voice interfaces, which is also kind of relevant. If you're interested, we can talk afterwards. So this lecture, I want to talk about a few things about why do we need multimodal interactions? What is multimodal interactions? What are the major problems about like why are you not seeing multimodal interactions on your phone right now? And I will talk about two of my work, which I think a lot of the systems and the details will be very relevant to you folks when you're building virtual assistant stuff. One of them is called React Genie, which is a multimodal app development framework. And the second is called Genie Wizard, which is addressing what I think the biggest problem that haven't been solved yet in multimodal interaction, which is the feature discovery problem. So I'll start by by talking about what is multimodal interactions. Today we have great GUI interfaces. Like one example for making slides is PowerPoint. In PowerPoint, you can have very accurate and powerful interactions. You have all of these different objects. You have text boxes, you have pictures, you have shapes. And you have fonts, colors, and line styles. And you can adjust everything accurately via graphical user interfaces by just clicking on it. However, currently it's kind of slow for applying actions to multiple objects. And for less common features, such as all of the stuff in those text boxes, you have to go through multiple clicks. And there's a lot of nested menus, as I just mentioned, and then it takes a long time to master all of them to actually make it work. So here are some examples of, well, how about we go back a little bit? So given this problem about like applying actions to a lot of objects kind of hard and less common features you have to went through a lot of clicks, what could be some good solutions, especially given all the virtual assistant stuff you have been working on during the quarter? Do anybody want to answer this?
Using your voice to kind of customize what you're designing?
Exactly. But there's a slight problem, which is if you use your voice, right, you can, people have been building this. I've seen some system about, oh, I describe what I want and generates a PowerPoint for me. But one small issue is that a lot of times you kind of want to work interactively with the agent, right? If we are working on a PowerPoint together, a lot of times what I would say, oh, it's like this box is a little bit small. And all of the titles and all of the slides, I wish it to be in another font and stuff like that, right? So those are kind of stuff, when people are communicating with each other, we're referring to stuff on screen. We are communicating the goals, and we are going back and forth with the agent. So this is kind of the goal. Some of the example of that includes, oh, like I want to make the text box bold in the slide master because all of the text boxes on the title should be bold. Or make the border of this shape with dots so that it's clearer that this is different from another slide. Or stuff like make everything right aligned, or make every shape on the slides above this part yellow because they mean different things. So here's an example of that.
Make all words React Genie red and bold.
Because I want to emphasize this word, right? And instead of the low-level actions where I explicitly select some word and make it red, I can just say, oh, make all the word React Genie red and bold. And instead of those low-level actions, I select, I change color, and make it bold 3 times. I just say this high-level actions. In fact, this idea of, oh, I can communicate what I want by using both gesture and voice is not new. Since 1982, wait, I said 1982, but this video must be earlier. So I think the paper and the video is published at a different time.
Put a magenta square there.
This guy called Richard Bold
Create
makes
a blue diamond
very
there.
revolutionary demo very early on.
Move that there.
Yeah, so this is the kind of things people visioned before. But right now, obviously, nobody's actually talking to their phone and touching their phone at the same time. I think and then I'll talk about why this is not widely adopted. My personal take is the most important issue is development cost. There are 3 set of very difficult stuff these days. If you want to implement multimodal interaction, you have to tackle all of them. There's compositionality of multimodal commands. There's we need to expose diverse actions and APIs inside a already built very complex GUI app. And we want to allow interchangeable and simultaneous multimodal interaction. That's similar to what has been demonstrated there. So let's recall the example earlier. Make this text box bold in the slide master, and all of the examples here. I wonder, based on what you have learned in this course, how would you implement those commands? And especially these days, we have LMs, unlike 1982, where I think most of the commands is just using pattern matching. Anybody want to talk about any potential ideas on this? Okay.
You can just parse the HTML and look for the property and change it to whatever you want it to be.
Yeah, and so you are saying you send the LM the entire web page, and you send LM the commands, and then the LM directly manipulates the web page. I think that's a great idea. That's actually a fantastic starting point. There's one thing I really like about your solution is that it's no longer limited to a single command at a time. You send the entire thing to LM. So it does not matter how complex your command is, LM will likely going to be able to do something about it. There's a few issues there. First of all, is that if you change the HTML, how do you save it? That's going to be an issue, right? If you say, "Oh, make this text bold," and then it changes the HTML of Google Slides to make this bold, when you hit save, nothing gets saved because you changed the graphical interface. So there's kind of a mapping problem, which is very interesting. And then there's also maybe it's not accurate. Maybe some of the stuff might not be able to be represented by HTML. So I think that's a great solution. One thing in the old days, when we start working on this, LM is not popular. We're working with GPT-3, like the old GPT-3, where you need a lot of prompting. So one thing previously people have been doing is kind of like the traditional the virtual assistant, where you use intent-based parsing, where you have a different function. You have a different function for every single thing user wants, right? This is actually worse than your solution. I think your solution is actually already better than the space that I'm targeting here. So if you say, "Oh, make this text box bold," then maybe you need one function to make text box bold in the slide master. If you make the border of the shape with little dots, maybe you need another function with a parameter called changing the border shape to a specific kind of border type. or make everything right aligned, you need another function for that. Make every shape above this doing something, you need another function for that. So this is pretty typical, right? This is, if you look up, like how do I integrate LM with my program, the recommended way is to do API calling, right? They call it API calling. But the problem with API calling is there's so many things. Once you look at a PowerPoint, there's so many things you can do. A lot of them involves a combination of different actions. And with the API interface, you translate them into single API calls, which you need millions of APIs to address millions of user requests. So that's not really scalable with just typical function calling. So what we really want to do, you can already see the pattern here. The way people address those problems is breaking down this request into smaller actionable actions. So for example, rather than say, make the text box bold as one function, I can first figure out what is the slide that the user is referring to. Then I figure out what is the slide master of this slide. And then I figure out what does this text box mean in the slide master. And then I change a property of the text box to the property that I want, which is make the font bold. And similarly, all of the previously mentioned actions can be translated in a similar way. By the way, this thing, if you have written object-oriented programming, you'll probably write function this way. This is called method chaining. And then we heavily rely on method chaining. We ask LMs to translate what the user wants into a bunch of actions using method training. And what I call this new language is like a new programming language I created for this. We created for this called NLPL, which is short for Natural Language Programming Language. And by compositioning multiple functions, imagine there's a million user requests, right? If you address each one of them, you have to write a million different functions. But if you decompose this million functions, every single one of them, to 10 different actions, then you probably only need 100 actions, 200 actions to address a million different user requests. When I designed this NLPL, I mentioned a little bit about method chaining, but in addition to that, we also experimented with a few different formats. This is kind of also interesting if you are working on some virtual system problem with LMs. Designing your own language and ask LM to parse is actually a great solution for that. So a few things we noticed, we tried different languages. We tried Python, we tried TypeScript, we tried something like Swift. The problem with Python is that it doesn't have strong typing, so it's not 100% sure which function you should call. So it results in more errors. And another thing, I don't know if you are going to design your own language, pay attention to that at least when I tried it, when it's like very early on, if your function call does not explicitly say parameters, I noticed like a lot of times the GPT will call the right function, but the parameters is in slightly wrong order. So I make the I make each one of the parameter explicit, which is kind of like how Swift designed their languages. One more thing is that we noticed a lot of the user queries are kind of like SQL, where there's a lot of filtering, there's a lot of like execution action for a bunch of items at the same time. So we kind of incorporate all of those features into this NLPL language. And to talk into more language features on NLPL, here's an example of a sentence. Change background color for all yellow shapes to orange. As typical English sentence, almost all English sentences at least have a verb, and which is change a background color for object, which is shape. And in this case, we slightly modify the verb. We say a change color to orange, the specific target that I want. And I also filter the shape by saying, I want only the yellow shapes. So as I mentioned before, we use something like object-oriented programming, which is you can call a function of an object. This is to solve a typical language structure where we have a singular object plus a verb. A lot of times, as I mentioned, you want like a SQL kind of sentence where you are applying one action to multiple objects. The NLPL supports automatically distribute action to a list of objects. So if you say, I want, I like all the food I ordered in my last order, then you can simply find out the order, list all the foods, and then call a single function. The function will get distributed into every single object in that list. There's also a bunch of other language features. Feel free to ask me about it, or just browse the React Genie source code, which is open source online. And all of the examples I've shown before about PowerPoint is actually real. So here's a demo for that.
Make all words React Genie red and bold.
This is the first example I've shown before.
Much better. And let's increase the font size a little bit.
By the way, there's a lot of voice recognition error, which is why I created
the font size of all text in this box to 24.
It looks much better. Okay. On the second page, we have the framework of React Genie. But the font is not clear enough. So let's change it to white. I can choose all boxes.
And make all text in this box white.
Great. And I also want the arrow to be white.
Make all arrows like this one white.
Great. As we can see, in the upper and the lower sections, we describe the state code and the UI separately. So let's make some difference. I can choose this one and
make all the boxes of the same size orange.
Great. Oh, but it looks like we need to change the font color back to black. So I will choose these two boxes.
Change the text in these two boxes to black.
Great.
Yeah, so that's to save time, I'll skip the rest of the examples. So we built this Genie PowerPoint app. It has 110 APIs involved, and then those 110 APIs can then be composed together to solve like a lot of different user requests. However, Genie PowerPoint is built on top of existing PowerPoint. They provide an API pack that allows me to access those APIs in JavaScript. But it doesn't support a lot of the common APIs you would need in making a PowerPoint, like animation, changing font color, and etc. The reason behind that is building a GUI is already a lot of work. To expose those API, even for a company as big as Microsoft, is a very, very hard task. Basically, we're asking developers to create a human interface, which millions of their developers are already using, and in some sense, an AI interface or programming interface, which currently not a lot of people are using. So they don't have enough incentive to build another entire interface. So we want to think about, in React Genie, how do we help developers expose those API with very, very little cost? So we start with what are people writing these days in like a typical web program. For example, this is React, and you typically in React, you write some logic code, which is the code that is actually powering all the state changes, and you have some UI code, which is rendering those state changes. What we really want to do is, rather than say, oh, like you have to write another type of APIs explicitly to allow people to do that, we want to make it so that you write the minimal amount of code. So we add something called annotations. Who here have write any annotations in their code? This is not comments. This is a thing called annotations. What have you used annotations for?
Just like various.
Okay.
Annotators for both Python and front-end logic. And
Yeah.
Can be data classes.
Right.
Caches.
Yeah, like one really interesting benefit of annotations is that from the compiler/interpreter side, you can do stuff with annotations. In fact, some of the language will translate the annotations into a bigger sized code in the compiler. Some of them is in the interpreter. When interpreter interprets them, they can see, oh, this specific tree structure in the code has been annotated with a specific tag. Then I could do something different with it. So this is basically the easiest thing we can think about to allow developers to expose something to the to AI models without changing their code structure too much. they simply annotate, oh, this class, I think AMI wants it, this function, the AMI wants it, and that's it. So this is a very easy way to expose those actions. When using a React Genie app, another thing will happen is kind of similar to, I don't know the name, but which is that like, oh, when I say something, I directly change the HTML, right? But if we take a different approach, where if you say something, we call some API to change states, then the problem becomes, how do we know what's your reference, how to reflect the changes? First problem is, oh, if I say, oh, like, when is the last time I ordered food from this restaurant? How do I know what this restaurant is by just if I click on it? Another problem is, oh, if I say, oh, order one more hamburger, right? And then it did change the state, but what if the UI didn't update? It's kind of the reverse problem of your example, where if you say, oh, order one more hamburger, I only change the HTML to update it by 1, but when I click order, it doesn't actually place the order. The other way is I'll actually change the backend state, but maybe the UI wasn't updated. How do the user know that their one burger order has been understood? Yeah, where's my burger? I didn't see that. And the other example is, oh, if I say, add 1 shake and 1 burger to the cart, right? And then we do it in the background, but the user didn't see anything. How does the user know that we understood and we have created that cart? So the user needs to know what has happened in the background. So what we did is we leveraged a concept called UI mapping. So we want to establish the mapping between what's happening on the UI and what's happening in the backend. When the user says, oh, like order something from this restaurant, we need to understand what that tap point represents in all of the objects in memory. Similarly, when the user says order a burger, we need to update the counter on the UI. And when the user says create a new order, we need to create that order and show that order, render that order in the GUI so that user knows something did happen. So basically, on the UI input mapping side, I need to know what object the user is tapping. On the output side, we need to know when there's some updates, I need to update the UI. When there's a new object that is not currently represented on the UI, we need to navigate the user to somewhere that the user can see the changes. So that's the 3 problems and the very rough solution that I just presented. And now I'll go into the details of how I have implemented the React Genie framework using all of the solutions I presented to solve all the problems I just presented. So React Genie tried to solve 2 problems. One is the ease of development. I want to make development very, very easy by heavily relying on annotations on top of existing React code. And the second part is I want to have very rich multimodal functionality. I want user to be able to say a very complex command. I want to have, they can do combination of voice plus GUI actions, and we want to show them the result accordingly. Here's a quick demo.
Today, Jack saw Emma's
attributing
photo,
React Genie.
and he feels this photo is very familiar. He must have seen it somewhere like that recently. Show me posts from John. So it's not John. What about posts from Mark? Wow, Mark has too many photos. Well, can you show me posts from Mark that I have liked before? So it's also not Mark. That's not it. What about posts from yesterday? Oh, that's it. It's Mary, actually. Well, share this post with Emma.
Yeah, so you kind of see the point where we build an app.
The other app we built is about NDA management.
Actually, we don't need the rest. But basically, we build an app that, and by building the app in React Genie, all of the functions exposed in voice. So you can have this very natural conversation with your app as if it's your friend. You can have back and forth conversation. You can mention to stuff. It can ask you to do stuff, and then it can work all the time. So quick crash course. I mentioned slightly before, all the GUI apps have states and state code, which is the logic behind it, and components code, which is how you display the UI for the users. And we basically ask developers to add some annotation in the state code to declare which class, which property, which function needs to be accessible through the multimodal interaction interface. And the components annotation, they annotate, oh, like this component represents that object in the state. So we have this very explicit mapping in both directions. When you tap on something, I know what it is. And when I need to render something, I know what class I need to use to render the results. I think the last course, if I check the class schedule correctly, you folks should understand learn about agent architecture on how to have a conversation with the user, right? Is the last course the agent? Yeah. Okay. Perfect. And in React, typically what happens is, when you tap on something, the UI responses, something got changed, and then the state got changed, and the UI automatically gets updated and being shown to the display. So React Genie kind of combines the two. The input can be text, it can also be touch. Or actually, this one should be UI input. But the UI input is mapped to both of them is mapped to the same execution state, which is we use React to manage the program state, and the result is both rendered as text through a response generator and through UI updates, so that when needed, I need to update the UI to let the user know. So I'll first talk about the response generator, the semantic parser and the response generator of React Genie. So I've just shown this NLPL earlier, right? And now the question is, given the stuff on the left, how do I generate the program on the right? Any ideas? You have learned semantic parser last lecture, right? So any ideas? How do we do this? Anybody want to give it a try? How do we, given the left, generate the right? Any idea is fine. Any idea is then better than no idea. Do you want to give it a try? Sorry, I don't know your name.
Sure, yeah. So I guess you would first feed the text to a semantic parser for.
Yeah, by the way, a hint. Semantic parser is backed by LLM. So how do you make LLM? How do you prompt LLM? We didn't even fine tune it. How do you prompt LLM to generate the thing on the right?
Give it like potential options, like functions that they can add. And
right.
Then
that's actually very close. So first of all, like how do I write the program, right? If you need to write a program, you would look at what are all the functions. You would look at these are. Oh, sorry. Do you have any ideas?
Can you just do like information retrieval on all the documentation and then shove that in the LLM and then ask it to do the thing?
That's actually an interesting idea because at the version we built, we didn't actually include that. But I think there are some potential situations where information retrieval will be super crucial. For example, if I say something like, search for posts about Lake Tahoe, right? And then I do need to do a little bit of retrieval of what are all the post content and which one matches Lake Tahoe. The code documentation.
If the documentation's too big, then it might overflow the context.
Yeah, exactly. It's very close. But what we observe is that, for example, even for PowerPoint, there's only about 100 or so API, although that's not complete. I think the complete API will be around 200, but that's actually totally feasible within the context of the LLM. So what we did, in fact, is we compile. Actually, I think the next slide have this. So first of all, we compile the code. We recompile the code so that we extract only the function declarations, kind of like documentation, where we actually have a spot in the annotation where developer can include some documentation if they want to. Those documentation we passed through the LLM. So yeah, so basically we show the documentation to the LLMs. And another thing we need to do, which is a new thing with React Genie, is because we have a new programming language. So if you just say give it some skeleton and then say, oh, generate a program, it will generate, I think, in our testing, it will be sometimes Python, sometimes JavaScript. It seems like those are LLM's favorite languages. So we want to generate our specific syntax, so we give it some few short prompts. And we give it whatever the user said, and then we ask it to generate the code that which we call parsed result. So this is the result of the semantic parser. Pretty easy. And for the response generator, we do similar things. We have the declaration, we have the instructions, we have the current interaction, and we also put the results. So for example, if you say, oh, order the food, and then I will return, oh, the actual order has been placed, and it contains this amount of food. And then the LLM will say, oh, like your order with a hamburger and fries has been placed. Yeah, so that's the semantic parser and the response generator. Next up is UI mapping. So basically in the UI map, the React Genie has a little runtime that when the app is running, is keeping a mapping between, oh, these are all the programming logic objects, and these are all the pixels on screen, and then which pixel maps to which object. And if the user click on the screen says, oh, reorder this food, then what we'll do is we'll first use the semantic parser to parse it into our NLPL language. And here, there is a special function we inserted for every single class called current. Current is whatever object the user is referring to. In this case, I need to figure out what is the food item the user is referring to by the tap point. So then I look at the UI mapping because I recorded which pixel range represent which object. And then I can resolve this, know that this is a food item, which is the crunch wrap from Taco Bell. And I can continue the execution using that object as food.current. So that's the UI mapping set. And there's a second part, which is how do we represent the changes to the user? So if the object's already on the UI, have anybody here write React or any kind of reactive UI frameworks before? Okay, so you would know that if a specific object, specific value in the state is being updated, then your UI automatically reflects that changes, right? So in this case, because we have the UI mapping module, we know a specific value, is it represented on the UI or not? If it's already represented in the UI, because the UI is written in a way where it's basically the UI is a mapping from state to HTML. So if I know that a specific thing is already being updated on the UI, then I do nothing. But I do nothing, but React will automatically handle it. If the object's not on the UI, this is the case where in a food, like this is like a recipe app. If you say, oh, show me creamy potato recipe, then I know what the object I want is a recipe called creamy potato, but it's not currently on screen. So what I will do is I will, because I know the mapping back as well. I know the mapping from pixel to state objects. I also have another mapping from state objects to a specific UI interface that can render this state object. So I would show that user interface that can render this object so that I get the response back to the user, so they know what has happened. And finally, it's the execution. The execution is basically interpreter that we build for NLPL. So one example is if I say, oh, make everything above this yellow. First thing I will do is using the semantic parser to parse it to something like this. And then I will start executing from the smallest component, which is slides.current, which we get from the user's context / the user's tap point. And next step is we iteratively parse. We first found out what are all the shapes. We then find out what is the point that I've been clicking, and then I filter out all the shapes that is above this, and then I make all of the shapes above this yellow, which is a typical interpreter. How do you interpret you do something with interpreter? From the developer's perspective, they simply write annotations on the GUI and on the state code. And we use the state code stuff to generate semantic parser, generate execution unit, to generate the response generator. And we use the UI part to generate UI mapping and UI update modules. So here is a wrap of what I just described. While the program is running, we have all the objects and all the UIs saved in memory. This is both provided by developers, and we know explicitly what are the mapping between the objects and the UI. And developer have those state code with annotations. And when the user says something like, reorder my last meal from this restaurant, and then click on a restaurant, we first parse it to our domain-specific language. And then we execute it iteratively. We first found out what is the tap point, which is resolved to the restaurant. In this case, it's Taco Bell. And we then figure out what are the order mapping to what are the order that I have ordered last time, which is this order I created in March 3rd. And then we figure out what are the food in that order, create a new order, and then we render the result back to the user, which is a page that renders an order. And the user can finally place that order. Yep. So we tested React Genie pretty extensively. We try to access for developers: is it expressive? Does it save development time? Is it easy to learn and easy to use? We built some demo apps, 3 different demo apps, and we noticed that only 5% of the code needs to be added for multimodal interactions, which is way less than, like, for example, PowerPoint. They have 100 APIs, but there's tons of code to actually make that work. And we also build a smaller demo app so that it can fit in the lab study. We can ask the developer to test it. And and then, in fact, the expert developer is me, because I just created this project. And then I try to write this either in React Genie or GPT-3 function calling. It takes way less time to write it in React Genie because I simply have to add some annotations. And GPT function calling is another level of complexity. And even then, because as I mentioned, I can only do one function call at a time with GPT-3 function calling, so it doesn't even match the same utility that I can provide with React Genie. So with React Genie, people spend less time, less code, and implement more features. We asked 12 developers to to change this timer app from only GUI version of the timer app. And then we know that they have high comprehension of the framework afterwards, and then they have very fast completion time, only about a little bit more than an hour. And a lot of people ask, if they can use this in their real-life applications. We also tested it if the generated app is actually helpful for the users. We first tested the language parser performance. We noticed that on 111 supported commands, the parser accuracy is very high, 91%. And note that most of those commands are multiple functions composed together, so it's actually a very hard task. And one thing we do notice is that for 71% of the unsupported commands, meaning that those commands are not actually currently supported by the app, we can actually generate sensible NLP, meaning that if it generates a function and the function exists, it would have solved the user's issue. So I'll actually mention more on that later. But another thing you want to pay attention to is actually within the app that we wrote, there's actually a lot of the commands that are not supported, and I'll talk about that later. Not supported meaning the feature just does not exist in the app. So if the user asks that, there's nothing that React Genie can do to help that. The developer has to provide new functions. We also ask 12 users to try an app built with React Genie versus an app that is GUI only. We find React Genie can save 40% of the time, lower cognitive load, and have higher usability. So the next project I want to talk about is called Genie Wizard, which is how to address this basically not enough feature problem about multimodal interactions. So as I mentioned previously, we have very good accuracy on the commands that are supporting, meaning if the app can do it, we can do it very well. But if the app cannot do it, then obviously there's no way React Genie can do. But we notice a very interesting thing, which is if it is a pure GUI app, then unsupported commands, meaning that you want to do something that is not supported by the app, it's kind of rare. Because if you click on a button, then you know you want that button to happen. Whereas if I give you an app and say you can do whatever you want with it, then people start talking about stuff they think is relevant, but might not be actually currently supported by the app. One example of that is, I think in the food ordering app we build, we have reviews for a restaurant, but we do not have reviews for food item. So people may say, oh, like order the most recommended food in a restaurant. It totally makes sense. If you go to a restaurant, you would ask a waiter/waitress, oh, I want something that you would recommend. But then when you do it with an app, it becomes very problematic. The problem is, how do we help developers how do we help developers know what commands need to be supported before their app is fully built? But an interesting thing is we observe that even for those unsupported commands, our parser can generate sensible NLPR, meaning that if those functions exist, it would be correct. Parses 53% of the time. In some sense, this is like hallucination of LLMs. It hallucinates a function that doesn't exist. But if the function exists, it would have solved the user's problem. So basically, the point of React Genie Wizard is trying to leverage this LLM hallucination to solve our problem, which is tell developers what are the functions they need to implement. Genie Wizard is IDE. So IDE has been around for a long time. IDE helps GUI developers save time. They help them follow GUI best practices. They help them visualize GUI designs. In our case, we have built this IDE that basically helps developers, when they're working on their code, we will give them guidance while they're working on it. And the guidance is in the format of suggested features. We'll say, we think for your app, these features might be needed for the users. And so in this little box, we will have a list of unique features. And every feature, if you expand on them, we will show you examples of, because the user want to customize their pizza, so you might want to create a new function called food item.customize. And then if you hover on a specific item, it will show you what are the generated user utterances. And while the user is working on their project, for example, they just added a new function, we will track in very quickly, refreshing half a second or something, tell you, what you've just done there supported another, let's say, in this case, 20% of commands that wasn't supported before. So the way we make it work is, I kind of alluded to a part of it, which is the second part, actually, which is how do I speculate on what functions are actually missing. And before that, we have to first simulate what users might want to use in your app. And finally, we want to create some feature suggestions for you so that you understand, so that you know you have some actionable item when you're working on a multimodal app. So the way we simulate user commands, I think I want to pause a little bit here. Anybody have any thoughts on, we have an app, or kind of halfly built. How can we simulate what user might want to do with the app? With LLMs, obviously. Any thoughts? I have an app, and then I want to know what user might want to do with it. as simple as possible. Go ahead.
Create a bunch of like profiles and tell the LLM they're that person, and then have them interact with the app.
Exactly. Very close. And one special thing we need to think about is how do you represent the app? So basically, we have the code signature. This is similar to React Genie, where we extract the code skeleton so that we can send it to LLM in a more compact format. We ask the LLM to first generate the app description. For example, this app is a digital menu app designed for dining in an Italian restaurant. This can be changed by the app designer developers if they want to target specific demographics or they have specific intention of their app. We send this app description, and then we have a persona generator. In fact, we use some UI census data to generate what we think is kind of representative of populations, but developers can change, can shift the demographics in whatever way they want. And based on the food app, it will come up with scenarios of, oh, this person is this age-year old and this is their job. They want to use this app because something. And from that, we generate interactive dialogue. So the user will say something and the app will respond in plain text. This is so that we can continue the conversation, but what we really want is only what the user said. And because this is a natural conversation, similar to human conversation, a lot of time they will have references to stuff, which is great for multimodal apps. The next part is to speculate on the missing features, which is similar to what I just mentioned before. You have interactive dialogue. We parse interactive dialogue into the DSL. And so as I mentioned, when the feature is supported, our parse accuracy is very high. So we can know that, oh, if a parsed result can be resolved within the existing functions, then it's very likely it's correct. And when the function is not supported, then it will 50% of the time it will hallucinate the right function. So we figure out what are the functions that are missing in those hallucinations. So that those are the driver results. By the way, among the 50% that are not correct, the hallucinated results are not correct, most of them actually directly generates not parsable React Genie DSL. We sometimes notice the LLMs tries to generate the implementation within the response. So we just simply discard them. So we get pretty highly accurate what we call driver result. This is using abstract interpretation, meaning that we interpret the React Genie DSL. When there's a missing function, we write down what are the missing functions. From the missing functions, we run a clustering algorithm called agglomeratory clustering on the embedding of those missing functions. We actually first ask LLM to say, oh, I know this is user's command. This function doesn't exist. Can you tell me what is this function for? So the LLM basically generates something like this, which explains a little bit of what this function is for. And then we cluster on top of that. The reason behind that is sometimes LLMs may generate two functions with the same signature. For example, persons.id could be a unique ID of the person, or it could mean their actual ID number, like their passport number and stuff. So based on the simulated user testing, we will be able to, from the code skeleton, we generate those commands, and from those commands, we generate actual functions developers need to implement. So that's a quick overview of the pipeline again. And from that, we render all of those results on the interface. We built 2 demo apps for testing Genie Wizard. And we asked 12 developers to, it's a within subject study, meaning every developer build one app with React Genie and the other app without the guidance of React Genie. We simply tell them, oh, try to add more functions to this app because think about what users might want to use in this app and just try to implement more functions. We asked them to improve the 2 test apps. One is a food menu app. One is a hotel booking app. And one of the tools is Genie Wizard, and one of them is just typical VS Code without the help of Genie Wizard. We actually had turned on Copilot for both of them, so that part is the same. There have been reviewers asking, oh, what if you turn on Copilot? Does it help? It doesn't really help. So we noticed that for both of the apps, the blue one is the baseline, and the orange one is Genie Wizard. The participant with Genie Wizard actually reduced the missing feature by more than 40%. It's half of the missing feature, just within. I forgot if I have the exact statistics here, but I think they did it within 30 minutes actually. So help them address 42% instead of only 10% of missing features within just a 30-minute session. So imagine how much you can do with this IDE if you're developing an actual fully fledged app where the development timeline is probably several months. So that's basically it for all the projects. A few things I want to just randomly have a discussion about. One thing which I found very interesting is that I think these projects kind of alludes to a new kind of system research in the era of all the AI systems. A lot of the system research, are people familiar what are the computer systems research? What area is counted as computer systems research? Any example other than what I have already shown here?
GPUs and stuff.
I'm sorry?
Building TPUs and GPUs and that stuff.
Yeah, kind of like that. Yeah, exactly. So a lot of the system research these days, especially related to AI, are about how do we accelerate training, how do we accelerate serving. But I think one thing super interesting to me is how can we, both of the projects in today's talk and a lot of the stuff, I don't know if, this is just me thinking, I don't know if Monica already mentioned this, but a lot of the stuff in this course is kind of about using systems research for those AI HCI problems, right? I try to make multimodal interaction easier to build, and Monica probably talk about how do you retrieve documents better and how do you do stuff better. In React Genie, I use this interpreter, which is like a compiler programming language concept. I build UI frameworks, which is like a software engineering stuff. In Genie Wizard, I use speculative parsing, which is a way of building interpreters and building program analysis. And I build IDE tools to help developers. This is also like a software engineering concept. So I found this very particularly interesting that in this new age of AI, you can truly use those AI to build better human systems using the techniques that have been invented a long time ago by computer system researchers. So I think this could allude into a new way of building new computer systems projects. And I think without LLMs plus these computer system concepts really makes it much more grounded and much more accurate. And you can do all sorts of different stuff. For example, I can analyze, what's wrong with the programs by using program analysis to know, maybe there's some hallucination happening. Maybe there's something wrong, so I shouldn't execute it. Maybe there's a function that is critical, so I need to show a specific UI to further conform that result before I just execute that. Like if you say, delete all my orders, right? And maybe I need to confirm that, maybe I need to ask you to enter password and stuff. So by building